Let us continue with the numerical problems. This is the third part of the numerical problems. At the same time, this is the fifth part of units and measurements. The SI unit of energy is kilogram meter square second raised to minus 2. And that of speed is meter second raised to minus 1. And the acceleration is meter second raised to minus 2. Which is the formula for kinetic energy K given below can you rule out based on dimensional arguments? So now it is, see, there are many ways of solving the problems. In this we can easily find out, because we know kinetic energy is half mv square, we know the formula. So the constant, we know that, okay, kinetic energy is half mv square, okay. So we know what is the equation mv square, and this is a constant for dimensionally it is no value. So it will be mv square only, whatever mv square is coming, I mean wherever mv square is coming, the equation will be correct, because dimensionally correct. I am not saying numerically correct, or maybe the answer is correct. We are not saying in other ways. Dimensionally it will be correct if the term mv square only is available in that formula. Okay. So even if actually it is some term is also added, that term is also having the same dimensional formula, then also we can say it's dimensionally correct. Okay. So the question is actually, we have to say whether it is dimensionally correct or not. So here only two terms are there with mv square. Half mv square, then 3 by 16 mv square. Both are actually mv square only. The constant you just rule out. It is not, you just ignore. So these two are anyway correct. Second thing is half mv square plus mv. We have to see whether m into a is having the same dimension of mv square. That's the only thing we have to check. Okay, other things, otherwise these two are dimensionally correct. Okay, first let's check actually m into a. M into a. Okay, now m into a is nothing but force. Force is not equal to energy. So this is also wrong. Okay, F is equal to ma is force. Force we know ml t raised to minus 2, whereas energy is equal to m l square t raised to minus 2. So this is not correct. So this is not dimensionally correct. Therefore, the principle of homogeneity will not apply here. So only these two are correct. Okay. Now that's one way of doing it. You can do it in the long way also. Okay. I'm saying the shortcut because these are numerical problems. You have to solve it within a within specific time limit. So the earlier you solve it, the better for you. That's what I'm telling you like this. So if you want to check the other things, actually you can check that also. First one is actually what is the m square v square. Okay, m square v square is actually m square v is l t raised to minus m, so l square t raised to minus 2. So it is, but we know what is energy, m l square t raised to minus 2. Okay, so this is not equal. So this is wrong. Okay, now next one is equal to, okay, mv square we know it is correct. Then ma k is equal to ma is force. So it will not come. Then number 3 16 mv square is okay. Then we have checked this actually, the last one, half mv square plus mv also we checked. Okay, ma is force, the force facility cannot be added together. So the answer is actually 1, 2, and 4 only. 3 is the answer, correct answer. Okay. Next one. Check the dimensional consistency of the following equations. What are the equations given? De Broglie's wavelength. So de Broglie's wavelength, this is a wavelength. Okay, this is the first thing. Wavelength means it is L. Okay, what is this? H by mv, where h is actually Planck's constant. Okay, m is mass and v is actually velocity. Let's check whether that's what is given there. Okay, v is velocity. So let us check that. So h by mv, we know what is h. H is actually energy by frequency. It's equal to m l square t raised to minus 2 by t raised to minus 1. It is actually m l square t raised to minus 1. So h we got. Now next is actually mv. So mv is actually mass into velocity. So m into l t raised to minus 1. Okay. So m and m get cancels here. T raised to minus will get cancels. So what we are getting is L and 1L will cancel. What we are getting is length. Okay. Length. So what is here we got wavelength. Wavelength is length only. So so therefore what happens? LHS is equal to RHS. Therefore this de Broglie's wavelength is dimensionally correct. Okay. Next one, next part is given is escape velocity. Escape velocity, the equation given is V is equal to square root of 2g m by r. So V, we know velocity is LT raised to minus 1. Okay, no doubt in that. Then G is the G is the gravitational constant. So we know that F is equal to G m1 m2 by r square, which implies G is equal to F r square by F r square by m square. Okay. So you can directly substitute that also here if you want. Then you can, it will get cancelled also. Then you will take better equation, that's also you will get. Okay, if you are substituting for G, then this M1 will get cancelled, R and will get cancelled. Okay, now you can substitute also. Otherwise, you can find out and you can substitute both ways. You can do that. Anyway, first let us find it out directly. That's actually easier for you. Okay, so F is equal to MLT raised to minus 2, okay, into L square divided by M square. So what is M raised to minus 1? L cube T raised to minus 2. So you got G here. Now square root of 2gm by r is equal to G. G is actually M raised to the 2 is a constant, therefore we are ignoring it. Okay, M raised to minus 1 L cube T raised to minus 1 into M divided by R. R is L again. Okay, the whole raised to half. So this M will get cancelled. 1L also will get cancelled here. Okay, so you will get L square. So you will get actually L square T raised to minus 2, the whole raised to half. It is nothing but LT raised to minus 1. Okay, this velocity. So you see what we are getting, escape velocity. LHS is escape velocity. Escape velocity is actually LT raised to minus 1. So LHS is equal to RHS. So it is also dimensionally correct. Derive the dimensional formula for the following physical quantities. Formula for the following physical quantities. First is actually tension. Okay, tension is nothing but force. Okay, so tension. So tension is nothing but force. So tension is equal to force. That is ML T raised to minus 2. We know that this means M into A. Okay, M is actually acceleration is distance by time square. So L by time square L T raised to minus 2 into mass. Okay, so it's clear. And next is actually velocity gradient. Velocity gradient. Velocity gradient. It is actually velocity by distance or length. Velocity by length or distance or whatever. So L T raised to minus 1 into L raised to minus 1 divided by L. Okay, so L and L will get cancelled. You will get T raised to minus 1. It is okay. Now linear mass density. So density, when we say, it is actually mass by volume. This is actually volumetric density. Okay, volumetric density. Then you can have mass by area. This is actually areal density. Okay, areal density. Then we can have mass by length. It is actually linear density, linear mass density. Okay, linear density. So mass per length, it is actually m divided by L is equal to m L raised to minus 1. Okay. Then we have impulse. Impulse is equal to force into time, delta t. Or it is the change in momentum also, you can say. Change in momentum. Means momentum is P1 or P2, that P1 minus P2. It is again P only, delta P, change in momentum. So impulse force, if you take the two formulas are there, if you take in force into distance, force we know ml square t raised to minus, sorry, ml t raised to minus 1 into t. Okay, ml t raised to minus 2 into t. So it will be 1 t will get cancelled, this ml t raised to minus 1. So if it is change in momentum, momentum is mass and velocity is equal to m L t raised to minus, velocity is L t raised to minus, again L t raised to minus 1. So the impulse is ml t raised to minus 1. Okay. Next one. Find the value of 60 joule per minute on a system that has 100 gram. Okay, system is having 100 gram. We have to find out 60. What is the value of 60 joule per minute? Okay, in a system having 100 gram, 100 centimeter. Okay, is for mass, centimeters for length. Then 1 minute is for second. Okay, so when we say 60 joule per minute, what is this? Joules is energy. Okay, by time. So what is energy by time? Energy by time is nothing but power. Okay, what is power? Energy is m L square t raised to minus 2 divided by time is equal to m L square t raised to minus 1. Okay, it is m L square t raised to minus 1. Okay, sorry, there is some mistake. It's not minus 3. This t when goes up, it is minus 3. So power is actually m L square t raised to minus 3. Okay, sorry for the mistake. Okay, this is the one. Now we know that 60 joules per minute is actually 60 joule per minute. When we change into seconds, we have to multiply by 60. That is actually 1 joule per second, nothing but 1 watt. Okay, so it is 1 watt. 1 joule per second is nothing but 1 watt. So we know that N1 U1 is equal to N2 U2, which implies N2 is equal to N1 U1 by U2. Okay, so N1 we know it is 1 watt. So U1 also in kilogram, meter and seconds. Okay, that is in SI units. So we have to find out for in another unit having 100 gram, 100 centimeter and 1 minute, what is the mean value? Okay, for 60 joule per minute. This is what we want to find out. So then we will write actually N2 is equal to N1 is 1 into our power is actually m L square t raised to minus 3. So we will write m is kilogram, 1 kilogram divided by 100 gram. Okay, it is in 100 gram. Okay, m raised to 1 we can say. Then L square, L is actually meter, 1 meter divided by 100 centimeter square into 1 second by 1 minute. Okay, 1 minute raised to minus 3. So it will be 1 into 1 kilogram will be converted to the same unit, 1000. Okay, gram per 100 gram raised to 1 into 1 meter is 100 centimeter again by 100 centimeter. Square into 1 second by 60 second. Okay, raised to minus 3. So gram will get cancelled, cm will get cancelled, second also will cancel. So what we will get 1 into 1000 by 100. 1000 by 100 is actually 10. Okay, 1 into what will get 100 by 100 is again 1 square by 1 by 60 raised to minus 3. Okay, 1 by 60, okay, minus 3. Okay, so what will get 10 into 60 cube. Okay, so you are getting 216 into 10 raised to 3 into 10. So okay, is equal to 2.16 into 10 raised to 6. Now 6 new units. It is the new unit. Okay, for N2 is the new units. Okay, the new units. So answer is 2.16 into 10 raised to 6 new units. Okay, it is equal to 60 joule per minute. Okay. Okay. Next question. A body of mass m, okay, is hung at one end of a spring, executes simple harmonic motion. A body of mass m, okay, it's called mass. Then end of a spring, okay, there's a spring, a body of mass m is hung and executes a simple harmonic motion. Okay, this is simple harmonic motion. Prove that the relation T is equal to, the relation we are prove is T is equal to 2 pi m by k. What is k? K is equal to spring constant. Okay, the force constant of the spring, that is spring constant. Spring constant. So what is spring constant? Spring constant is equal to F is equal to minus kx. Okay, we have already discussed all these things in another problem, so you may be remembering that. Okay, so one spring is there. Okay, that is the force we are executing. Then the spring will get elongated, and the distance is x. Okay, then there's a restoring force F will be there. Okay, so F is good because the movement, I mean the direction of the restoring force and the elongation are in different directions. We are giving the minus sign. So K is equal to F by X. It's already these things explained with the diagram. If you have not seen that, please watch the previous video. Okay, part 2 or the numerical problems. If you're watching, actually you will get all these explanations. Okay, with diagram. Diagrammatically it was explained. So K is equal to F by X. And what is F? ML T raised to minus 2, X is again L. So what we will get? MT raised to minus 2. So K is MT raised to minus 2. Okay. So the expression is 2 is equal to 2 pi m by k. Okay. So T is actually the time period. Therefore, left hand LHS is equal to T. Okay. So right hand side, let us see. Right hand side is equal to 2 pi. Okay, we can ignore m is equal to m divided by m t raised to minus 2. Okay, m will get cancelled. We get actually t square. Okay, which is not equal to LHS. RHS is not equal to LHS. RHS we got right hand side, we got actually dimension t square, whereas LHS is actually t. So these are not matching. So it is not non-dimensionally correct. Now the next part of the question says actually, then if that is the case, what is the correct equation? Find out the correct equation. So it's given T is proportional to m raised to a and k raised to b. Okay, it is actually related to mass and the spring constant. So what is the relation only we have to find out. Okay, so it's proportional to m anyway, it is m raised to a k. We know that it is m t raised to minus 2 raised to b. Okay, so it's proportional to m raised to a plus b and t raised to minus 2b. Okay, here it is t raised to 1, m raised to 0, l raised to 0, t raised to 1. So we can equate a plus b is equal to 0. Okay, then minus 2b is equal to 1, which implies b is equal to minus 1 by 2. If b is equal to minus 1 by 2, a is equal to 1 by 2. So if you are substituting the values of a and b here in this equation, we get t is proportional to m raised to half, then k raised to minus half. That means square root of m by k. Okay, proportional to the problem. If you remove, this is the and there is a constant t is proportional to constant. What will be the constant? Okay, if you have constant k already we have used here, so we'll use actually maybe n. N is a constant, you say, then square root of m by k. So we know that it is actually 1 by, we know it is 2 pi. Okay, it is 2 pi. So if it is 2 pi, then that will be t is proportional to 2 pi root 1 by k. So let us, for the time being, because that is not given in the equation, therefore we will say like that t is proportional to root of m by k is the equation. The frequency of vibration of stretched string depends on its length. Now, given the frequency of vibration depends on its length L, then the mass per unit length, okay, mass per unit length m, okay, mass per unit length, then it is the tension T. So tension raised to C. The frequency of vibration stretched string depends on the length, the mass, and the tension. Length we know the dimension is L, then mass per unit length. Mass per unit length is mass per length is equal to m L raised to minus 1. Okay, mass per length. Then tension is nothing but force. So T is equal to m ml T raised to minus 2. Tension is nothing but force. So we can say T raised to minus 1 frequency. The dimension of frequency is T raised to minus 1 is equal to, when you change the proportionality constant, it's a constant into L. L we know L itself, L raised to A. Mass per unit length is actually m L raised to minus 1, the whole raised to B. Then T is m, tension is force as m L square T raised to minus 2 into C. So it's equal to K L raised to A minus B plus 2C. Then T raised to minus 2C. M raised to B plus C. B plus C. So that is actually m raised to 0, L raised to 0, T raised to minus. So we can equate B plus C is equal to 0. Then A minus B plus C A minus B plus C. A minus is not 2C. L is actually ML. Force is ML, not ML square. This is C. So A plus B plus C is equal to 0. Again, minus 2c is equal to 1, which implies c is equal to minus 1 by 2. If c is equal to minus 1 by 2, b is equal to half. Okay, from here, c is equal to minus 1 by 2, b is equal to half. Okay, then if you substitute here, a minus b, then b, what will be? B is equal to half. Okay, c is equal to b is, sorry, c, what we received is actually minus 2c, minus 2c is minus 1, so okay, actually it's a mistake. So c is equal to plus half. So b is equal to minus half here, okay, because it is minus 2, c is equal to minus 1. So c is equal to plus half, b is equal to minus half. For a, minus is plus. So c is again plus half is equal to 0. So a is equal to minus 1. A we got as minus 1. So if you substitute these values, what you will get? F is proportional to, or F is equal to K. So you can say L raised to A is, what is A? A is equal to minus 1. L raised to minus 1. Then M raised to B. B is equal to minus half. Okay, minus half. Then T is equal to plus half. Which means, what does that mean? K by L. Okay. K by L raised to minus exactly K by L into square root of T by M. Okay. So, it's equal to F. This is the formula. This will be the expression. Okay. Next question. The time of oscillation T. Okay. Time of oscillation T of a small drop of liquid under surface tension whose dimensions are of those of force per unit length. Okay. So, a surface tension force per unit length. It is already told. Dimensions of force per unit. That is ml T raised to minus 2 by L is equal to m T raised to minus 2. Already it is given. It is force per unit length. So we found the dimensions of surface tension. So it is given time of oscillation of a small drop of liquid under surface tension is proportional to, depends upon what? The density D. Okay. So D raised to A. Then the radius R raised to B. Then the surface tension. Okay, sigma. Okay. So we found actually what is surface tension. R we know it is L. Then it is density. Density we know that mass per volume. So M L raised to minus 3. Okay. So what is given? T raised to minus 1. M raised to 0. L raised to 0. T raised to minus 1 is proportional to M L raised to minus 3 density raised to A. Then R is radius. So L raised to B. Then actually surface tension M T raised to minus 2 raised to C is what is given. So it's proportional to M raised to A plus C, then L raised to minus 3A plus B, then T raised to minus 2C. Okay, so M raised to, then we can write A plus C is equal to 0, then minus 3A plus B is equal to 0, and minus 1 is equal to minus 2C, which implies C is equal to 1 by 2. Okay. So, sorry, is it minus 2C? Minus 2C is equal to, so C is not, okay, now what happened, it is not T raised to minus, it's plus 1, okay, it's actually time only, it is plus 1 only, therefore plus 1 is equal to 2C and C is equal to minus half. Okay, sorry for the mistake. Okay, so C is equal to minus 1 by 2. When C is equal to minus 1 by 2, then A is equal to half. Okay, so A is equal to minus C, therefore A is equal to half. When A is equal to half, minus 3 into 1 by 2 is equal to B. Sorry, minus 3 1 by B plus B is equal to 0, which implies B is equal to 3 by 2. So we got A, B and C. So T is proportional to D raised to A. What is A? Raised to half. Then what is R raised to B is 3 by 2. Okay. Then sigma raised to C. What is C? Minus half. Okay. So minus half. So it's equal to square root of D. Okay. 3 by 2 is R cube. Okay. By sigma. So square root of dr cube by sigma. That is the answer. Okay. Significant figures. So we know that 0.072, there are 2 significant figures. 12.0000, there are 5 significant figures. So 0.60 actually the trailing zeros are, so that not the trailing zero, because yeah, the zeros actually, yeah, I mean to cut the position, okay, after the decimal below 1, then such things actually it will be, it is not significant. Okay, after the decimal, between the decimal point and the non-zero digit, what are the zeros coming? These are insignificant. Okay, but after the non-zero digit, the zeros coming are significant, because that's 60. So number of significant digits is 2. 3.008 and 10 raised to minus 11. The 10 raised to 11, the power is insignificant, therefore only 3. 1.2340. Okay, so here actually all 5 are significant. 0.04 only 1. Okay, now 5,000 we can write 5 into 10 raised to 3. Therefore it is only 1. Now the length of the wire measured as 10 centimeter, 10.1 centimeter, 10.2 centimeter, 10.3 centimeter, 10.4 centimeter respectively. Find the absolute error. How will find the absolute error? For finding the absolute error, you have to find the mean first. Okay, the true value. How will find the true value? For the true value, you have to add all the the events. Okay, all the 1, 2, 3, 4, 5 events you have to add together. Okay, then you have to take the average of that. So here actually you have taken the average of the all 5. So you will give 51 divided by 5 is 10.2. Now error is equal to true value minus measured value. Measured value is 10.1, 10.10, 10.1. Okay. So like that, the true value is 10.2. The first one is 10.2 minus 10 is 0.2. Like that, you can find out the absolute error. Okay, absolute error you will find out, and then all the absolute errors you are finding out. Then you will find the mean absolute error. When we find the mean absolute error, it will be the modulus value. So the all modulus will divide by 5. By number of observations. So you will get actually 0.12 centimeter. To find percentage error, you have to multiply it by 100. So you will first you have to find the relative value. You get the mean value only. First actually you have to find the relative value. Relative value actually the mean absolute error divided by the true value. Okay, when you multiply it by 100, you will get the percentage error. Okay. The Young's modulus of steel. Okay, Young's modulus of steel is 1.9 into 10 raised to 11 Newton per meter square. Find the value when expressing CGS units. We know in CGS unit 1 Newton is equal to 10 raised to 5 day. So Newton per meter square is equal to 10 raised to 5 divided by meter when changed into centimeter is equal to Newton per meter square is equal to Dienes per centimeter square. Centimeter square is equal to meter is to be multiplied by 10 raised to 4. Okay, 10 raised to 4. Dienes per centimeter square. So y is equal to 1.9 into 10 raised to 11 into 10 raised to 5 by 10 raised to 4. Okay, 5 by 10 raised to 4 is equal to 1.9 into 10 raised to 12 Dienes per centimeter square. Next one, if x is equal to a plus bt plus ct square, x is in meters length, then t is in seconds. T is in seconds. Okay. Then what is the dimension formula A, B, and C? So x is in meter means it is dimension is L. Okay. So it's equal to A is equal to BT is equal to CT square. Okay. So therefore A is equal to L. Okay. Now L is equal to B into T, which implies to get A, B into T means T raised to minus 1 into T, it will become 1, then we get L, we have to multiply by L. So B shall be L T raised to minus 1. So B is equal to L T raised to minus 1. Okay, nothing but velocity. Okay. No problem. And now next is actually L is equal to A T square is equal to T raised to minus 2 into L. Okay, then only T raised to minus 2 into T square will become 1, then L will be balanced. Therefore, you will get both sides L. Okay, that means L T raised to minus 1 is actually C. So C is equal to L T raised to minus 1. Now, what are the dimensions of A and B in relation F is equal to A plus Bx, where F is equal to force, then X is distance. Okay. So we know that ml T raised to minus 2 is equal to A is equal to B X. Okay. So for B is equal to ml T raised to minus 2 divided by X. X is actually nothing but L. Okay. L will get cancelled. The B is equal to mt raised to minus 2. Okay. Now again A is equal to ml T raised to minus 2 itself. Okay. Next one, find the dimensional formula for kinetic energy and pressure. Okay. So we know that at kinetic energy, nothing but energy, it is ml square T raised to minus 2. Okay. Now pressure is equal to force by area is equal to ml T raised to minus 2 by L square, that is ml raised to minus 1 T raised to minus 2. Okay. State dimensional formula for stress, strain, and Young's modulus. So stress is equal to pressure itself is equal to force by area is equal to m L raised to minus 1 T raised to minus 2. This now we have found out here. Okay. Now strain is actually delta L by L. So it is a ratio of two lengths. So it has no dimensions. No dimensions. Okay. Young's modulus is equal to stress by strain. It's equal to strain no unit. Therefore, these are the same unit as the stress. Okay. So it is having the same limit as the stress, that is m L raised to T raised to minus 2. Using relation E is equal to HF, obtain the dimensions of Planck's constant. So Planck's constant we know is E by F is equal to M L square T raised to minus 2 by T raised to minus 1 is equal to M L square T raised to minus 1. Now, magnitude of force experienced by a certain object moving with speed b given by F is equal to kb square, where k is a constant. Find the dimensions of k. So, given magnitude of force experienced is equal to ml T raised to minus 2 is equal to given k v square. Okay. Where v is the speed is equal to k into L T raised to minus 1. The whole square is equal to k L square T raised to minus 2. So k is equal to ml T raised to minus 2 by L square T raised to minus 2. So minus 2 will get cancelled. 1 L will get cancelled. So it is m L raised to minus 1. Okay. What is m L raised to minus 1? M L raised to minus 1 is equal to mass by length. Length is equal to linear mass density. This is linear mass density. Next one. The rotational kinetic energy of a body is given by, okay, rotational kinetic energy is given by E is equal to 1 by 2 I omega square. I omega square. Okay. So energy is equal to m L square T raised to minus 2. Is equal to I means mr squared into omega is raised to minus 1, so T raised to minus 2. So it's equal to m L square T raised to minus 2. It's correct. Rotational motion. Okay. Rotational motion m replaces I, mi and b by omega. Okay. I by okay. In linear motion, E is equal to half mv square. Okay, linear kinetic energy. Rotational kinetic energy, it is half I omega square. Okay. So I is equal to moment of inertia. Okay. Here I is equal to I is moment of inertia. Therefore, the mass is replaced by moment of inertia and a linear velocity B replaced by omega, angular velocity. So E is equal to half I omega square. So okay, E is equal to half I omega square. So I is equal to E by omega square is equal to m L square T raised to minus 2 by T raised to minus 2. So it will be m L square. I is equal to m L square. Okay. Because the question I have not written properly. That's why I have done all the things here. But actually it is the same anyway. But the one we wanted to find out is actually I, moment of inertia. So m L square. Now a book with many printing errors contains 4 different formula for the displacement. So that displacement is y and dimension is for that L. And for this displacement in a book with the printing errors, 4 different formula are found. Okay. For the displacement of particle undergoing certain periodic motion. We want to find out which one is correct and which one is incorrect. So let us take the first case. First case, we know that actually sine of 2 pi t by t is dimensionless. So 2 pi anyway, it is a constant. Therefore, that we can remove. Therefore, t by t, if we take the dimension, it is dimensionless only because it is t by t is actually it will become dimensionless. So sine 2 pi by t by t is dimensionless, and then y will become a. So is equal to dimension of L. So dimension of A will become L. Okay, it's correct. Second one is equal to y is equal to A sine Vt. Okay. Now A sin Vt means actually V is actually velocity, then actually it is Lt raised to minus, because actually the sin Vt is not dimensionless, so that is wrong. Third one is into A by T into sin T by A. So again, actually sin T by A, if we know that A is L, then sin T by A is not dimensionless, so that is also wrong. Even otherwise, if you are taking, you are not considering any other thing, if you are taking a T and A, the same, if you think sin T by A, and then you equate T and A should be T, then actually again, okay, for example, sin T by A, another method we are checking, actually we are not considering the former things, only this thing also we are checking, sin T by A should be dimensional, for this to be dimensionless, A should be is equal to T. In that, if that is the case, A by T is equal to T by T, this will be 1, okay, then actually, but the left hand side Y is equal to L, so these two things, and the right hand side is dimensionless, so it is wrong, the expression is wrong, it is not dimensionally not same, it is the principle of homogeneous equations are violated. Fourth one, A by root 2 into sin 2 pi T by 2 pi T, so sin 2 pi T by T, here actually T by T is dimensionless. Similarly for cos 2 by T also, there is also dimensionless. Therefore, it is dimensionally correct. Now, the equation of state of real gases can be expressed as, state of the real gases can be expressed as actually the real gases, for real gases, P is equal to A by B square into B by B, where B is equal to volume, P is equal to pressure, is equal to R into T. R is equal to universal gas constant. Okay. Then T is equal to temperature. T is equal to temperature. Okay. If this is the case, where P is pressure, B is volume, T is absolute temperature, then find dimensional formula for A and B. We have to find the dimensional formula for A and B. So in this equation, we can write A, P is equal to A by B square, which implies A is equal to P, B square. P is actually pressure, F by A, so MLT raised to minus 2 by L square, okay, and then B square is equal to, B is volume is L cube, B square is L raised to 6, okay. So what we will get? We will get M L raised to minus 1, T raised to minus 2 into L raised to 6, so we will get M L raised to 5, T raised to minus 2, okay. So A is equal to M L raised to 5, T raised to minus 2. Now again we can write V is equal to V. From here we can write V is equal to B. So V is actually L cube. So V will be L cube. The speed of sound in salt is given by formula. Speed of sound, okay. Speed sound given by square root of E by rho, where E is equal to coefficient of elasticity. Coefficient of elasticity, okay, and rho is the density in the given sound, density. So check the relation by method of dimensional analysis. Now we have to check the relation B is equal to check dimensionally E by rho. It is given that E is equal to coefficient of elasticity. Coefficient of elasticity can be Young's Young's modulus, or it can be bulk or shear modulus, because coefficient elasticity can be, it is actually stress by strain, okay. It is stress, elasticity is actually stress by strain. Strain is anyway, it is dimensionless, it is a ratio of two lengths. Stress is equal to pressure, okay. So pressure is equal to F by A is equal to M L raised to minus 1 T raised to minus 2. So this is the dimension for that. But actually when it is Young's modulus, it is linear stress by linear strain. When it is bulk modulus, it is volumetric strain by volumetric strain. In shear modulus, it is shear stress by shear strain. Okay, like that it will change. But whatever be the case, it is stress by strain only. So strain is dimensionless. Okay, so and the stress is equal to ml raised to minus 2 raised to minus 2. Now again, density is equal to mass by volume is equal to ml raised to minus 3. Okay, so v is the velocity or speed, so lt raised to minus 1. That is the dimension for v. Okay, now we have to check actually LHS and RHS. LHS we got lt raised to minus 1. Then right hand side is equal to e by rho raised to half. Okay, because the square root. E, we know that m l raised to 1 t raised to minus 2, then m l raised to minus 3 is for density. So what you will get? You will get L square t raised to minus 2 raised to half. It's nothing but LT raised to minus 1. So it is velocity again. Therefore, LHS is equal to RHS dimensionally. Therefore, it is dimensionally correct. Next question. Next one is, there are 4 quantities given: angle, strain, relative velocity, relative density. Identify the quantity which has the unit, which is a unit but no dimension. Let's take the first case. First case is actually angle. Angle is actually arc length by radius. So it has no dimensions anyway because it is the ratio of 2 lengths, but it has a unit. Okay, unit is radians. Okay, radians is the units. So the quantity which has a unit but no dimensions is a quantity which has a unit and no dimensions. Okay, unit is radians. Now second one is strain. Okay, strain in the case actually strain has no unit or no dimension. It's a ratio of length by length. Okay, so relative velocity is a it is actually it's a velocity of one object with respect to other. Okay, for example, a train is moving in north direction 10 meter per second speed. Okay, but another train is moving in south direction in 5 meter per second speed. Then what is the relative velocity? Relative velocity, the difference between the two, you will get actually 5. 10 minus 5 is 5. It is the with respect to one, what is the speed of the other? So again, it is a velocity only. So it will have a unit. It will have a unit. Okay, it is 5 meter per second. It has a unit. Okay, even though relative velocity with respect to this actually it is a unit also. It is a unit. So that may be relative velocity is one is the velocity one object with respect to other. Okay. So it has dimensions same as velocity, and it has a unit also. Dimensions and unit. It has dimensions and unit. Okay, it has dimensions and unit both. Okay. Now next one is relative velocity. Then relative density. Relative density is actually the densities of it is ratio of 2 densities. Therefore, it has no unit. Okay, it has no unit and it has no dimensions. So our question here is, if it is have a unit but no dimension, that is angle. Okay. The depth x to which the bullet penetrates human body. So human body, to what depth a bullet penetrates the human body depends upon coefficient of, that is proportional to coefficient of elasticity eta and coefficient of elasticity eta and the kinetic energy. Okay, E, kinetic energy E. So we know that eta, coefficient of velocity, is equal to stress by strain, is equal to, stress is nothing but pressure. So force by area is m l raised to minus 1 t raised to minus 2. So coefficient of velocity is actually m L raised to minus 2 T raised to minus 2. Then kinetic energy is nothing but energy, therefore it is m L square T raised to minus 2. Okay. Force into distance. Force is force into distance. Force is ml T raised to minus 2 into distance is L. It is m L square T raised to minus 2. Okay. Okay. Now, x is actually the distance of penetration. So, LHS is equal to L. Okay. M raised to 0, L raised to 1, T raised to 0. Okay. L is equal to 1 is equal to, okay, or proportional to whatever, eta. Eta is actually coefficient of elasticity. So, coefficient of elasticity is m L raised to minus 1 T raised to minus 2 the whole raised to a. Then it is the kinetic energy. Kinetic energy is actually m L square T raised to minus 2 or raised to b. So it's proportional to m raised to a plus b. M raised to a plus b into L raised to minus a plus 2b T raised to minus 2a minus 2b. So we can write like this: a plus b is equal to 0. Okay, when you are substituting here, a plus b is 0, then L is 1. So minus a plus 2b is equal to 1. And third equation is minus 2a minus 2b is equal to 0, which implies a is equal to minus b. Okay, a is equal to minus b. If a is equal to minus b, here we are substituting for b. So minus of a is equal to minus of minus b. Okay, plus 2b is equal to 1. That means 3b is equal to 1, which implies b is equal to 1 by 3. If b is equal to 1 by 3, a is equal to minus 1 by 3. Okay, because b is equal to minus a. A is equal to minus 1 by 3. So a and b we got. Okay, therefore x is proportional to eta raised to a, e raised to b is actually eta raised to a is minus 1 by 3. Okay, 1 by 3, then e raised to b is 1 by 3, which is nothing but e by eta the whole raised to 1 by 3. So we are supposed to prove x is proportional to e by eta 1 by 3. This is proved. So the expression is proved. X is proportional to e by eta the whole raised to 1 by 3. Rule out or accept the following formula for kinetic energy on the basis of the dimensional arguments. So given first one is given 3 by 16 mv square. Second one half mv square plus mv is equal to k. So in this case, what happens? We know that energy is equal to m L square T raised to minus 2. Okay, so we have to check actually whether we are getting this. So the left hand side should be m L square T raised to minus 2, then right hand side should actually match with this. So in 3 by 16 mv square, we know it is instead of half mv square, 3 by 16, whether the 3 by 16 half or pi or whatever with k, that constant is not considered since it is dimensionless. Only mv square will be considered, half mv square. The formula for kinetic, therefore it will be correct actually. M into p square is equal to m L T raised to minus 1 the whole square is equal to m L square T raised to minus 2. It is dimensionally correct. Second case is actually if k is energy, m L square T raised to minus 2, then it should be same as the first term and the second term. So here it is correct. It is equal to m into a is nothing but force. So force and energy cannot be added. Therefore this is dimensionally wrong. This equation is dimensionally wrong. Find the dimension formula resistance. So resistance is equal to V is equal to IR. We know V is equal to IR, therefore R is equal to P by I. So V is nothing but W by Q into I. So is equal to work is ml square T raised to minus 2 divided by Q is A into T into A. So it is M L square T raised to minus 3 A raised to minus 2. Okay. Find out viscous force acting on a tiny steel bar of radius R moving in a viscous liquid of viscosity eta with the constant speed v by the method of dimension analysis. So F is viscous force, okay, R is radius, then viscosity is equal to eta, okay, v is actually speed. Now we know force, then force is proportional to eta raised to A, radius raised to B, velocity or speed raised to C. Okay, so we know force is equal to mlt raised to minus 2. We all know proportional to eta is equal to viscosity is F into L divided by VA. So F is mlt raised to minus 2 into L, okay, divided by velocity is LT raised to minus 1 into area is L square. Okay, area is L square. So it is L and L get cancels. Then 1 L get cancels here. Okay, now it is M T raised to minus 1, T raised to minus 2 get cancels. L raised to minus 1, T raised to minus 1. Okay, it will be M L raised to minus 1, T raised to minus 1. Okay, that is eta. So M L T raised to minus 2, eta is we got M L raised to minus 1, T raised to minus 1 raised to A, R is equal to L raised to B, B is equal to L T raised to minus 1 raised to C. So simplify, what we will get M L T raised to minus 2, okay, is equal to M raised to A, L raised to minus A plus B plus C, and T raised to minus A, then minus C. Okay, so we get M raised to A, L raised to minus A plus B plus C, T raised to minus A minus C. Okay, which implies if you M L T raised to minus 2. Okay, so M raised to 1, L raised to 1. So we will get A is equal to 1, then minus A minus C is equal to minus 2. Okay, which implies minus 1 minus C is equal to minus 2. So C is equal to plus 1. Again, minus A plus B plus C is equal to 1. Okay, L plus 1. So A we know plus 1, so it is minus 1 here. C is equal to plus 1, so plus B is equal to 1, which implies B is equal to 1. Okay, minus and plus 1 get cancels. So we got A, B and C. So when we get A, B and C, so F is proportional to eta raised to A. What is A? A is 1. Eta raised to 1. Then R raised to B. B is 1. Then V raised to, what is C? C is also 1. So we are getting F is proportional to eta RV. Now F is equal to K eta RV. Now the value the value of K is equal to 6 pi in real formula. Real formula it is actually F is equal to 6 pi eta RP. Okay. Dimensions of energy density. Next question is dimensions of energy density. Now energy density is equal to energy by volume. So energy is, we know that ml square t raised to minus 2. Volume is actually L cube. Therefore it is ml raised to minus 1 t raised to minus 2. Check the dimensional consistency of the relation V is equal to 1 by L into square root of P by rho, where V is equal to velocity, okay, P is equal to pressure, rho is equal to density, and L is equal to length. Okay, so we know the dimension of V is equal to LT raised to minus 1. Okay, then P is equal to F by A, pressure by A is equal to M L raised to minus 1 T raised to minus 2. Rho is equal to mass by volume M L raised to minus 3. Okay. Now substituting in this equation, then L T raised to minus 1 is equal to 1 by L into M L raised to minus 1 T raised to minus 2 divided by M L raised to minus 3 the whole raised to half. Okay, is equal to 1 by L means L raised to minus 1 into M get cancels, then it is L square then T raised to minus 2 the whole raised to half. It's equal to L raised to minus 1 into L T raised to minus 1. So it is T raised to minus 1. But actually left hand side is equal to L T raised to minus 1. Therefore it is not dimensionally correct. Okay, because the letter RHS is LHS is not equal to RHS dimensionally. Okay, therefore it is not dimensionally correct. So then the equation is not dimensionally correct. Now the refractive index mu of a medium is found to vary with the wavelength lambda as mu is equal to A plus beta lambda square. Okay, lambda is equal to wavelength. Okay, then mu is equal to refractive index. Okay. Refractive index. So refractive index being a ratio of similar quantities. Okay, similar quantities is dimensionless. That means m raised to 0, L raised to 0, T raised to 0. Okay, it's equal to A plus B L square. Okay, because lambda is equal to L. Okay, so what does that mean? This means actually m raised to 0, l raised to 0, then t raised to 0 is equal to a is equal to bl square. Okay, so b is equal to l raised to minus 2. Sorry. So is it b lambda square? b lambda square, sorry, b a is equal to bl square. For this being dimensionless, b should be l raised to minus 2. Yeah, there is a small mistake in the actually what I have written. It is not b by lambda square. Okay, so it is b by l square. So it's b by l square. That means actually b is equal to l square, not lambda square. Okay, l raised to minus 2. So b is equal to l square. Okay. Dimension of b will be l square. Similarly, okay. Similarly, a is equal to dimensionless. M is 0, L is 0, T is 0. A is dimensionless. As per the principle of homogeneity. Okay. Now next one, find the dimensions of a by b. What we are to find out a by b. Okay. Now p is equal to ax plus bt square, where p is equal to pressure is equal to m l raised to minus 1 t raised to minus 2 f by a. Okay. Now x is distance, x is equal to distance. Okay. And t is time, of course, t is time. Now what happens? From this, p is equal to ax is equal to bt square, bt square. So m l raised to minus 1 t raised to minus 2, okay, is equal to a into l, which implies a is equal to m l raised to minus 1 t raised to minus 2 by l. So m l raised to minus 2 t raised to minus 2. Next one, p is equal to bt square, which implies m l raised to minus 1 t raised to minus 2 is equal to b t square, which implies b is equal to m l raised to minus 1 t raised to minus 2 by t square. So m l raised to minus 1 t raised to minus 4. So a by b is equal to m l raised to minus 2 t raised to minus 2 divided by m l raised to minus 1 t raised to minus 4. M get cancels. So what we are getting is actually l raised to minus 1 t square. A by b is l raised to minus 1 t square. Okay. Next is in Van der Waals equations. What is Van der Waals equation? Van der Waals equation. Okay, p plus a by b square into v minus b is equal to r into t, where r is actually universal gas constant, t is temperature universal gas constant, t is actually temperature in Kelvin or absolute temperature. So v is volume is equal to L cube. Okay, Then P is equal to pressure is equal to M L raised to minus 1 T raised to minus 2. Okay. So if this is the case, P is equal to A by B square naturally. Okay, P is equal to A by B square. That is M L raised to minus 1 T raised to minus 2 is equal to A by L raised to 6. E square, volume square is L cube, the whole square is L raised to 6, which implies A is equal to M L raised to 5 T raised to minus 2. Okay, A is equal to M L raised to 5 T raised to minus 5. Again, T raised to minus 2. Again, P is equal to, again, B is equal to B. From this, we can say B is equal to B. So, it's equal to L cube. So, B is equal to L cube. One second. So, B is equal to B is equal to L cube. B is equal to L cube. A is equal to M L raised to 5 T raised to minus 2 and B is equal to L cube. Next problem. Find the dimensions of A by B. We have to find out A by B. Okay, A by B. Now, the relation is P is equal to A minus X square by BT. Where X is distance, P is pressure. P is pressure. P is pressure means actually M L raised to minus 1 T raised to minus 2 is equal to P. Now, from this, we can say A is equal to X square is equal to L square. So, A is equal to L square. Now, M L raised to minus 1 T raised to minus 2 is equal to L square. Here actually both are have the same dimension, therefore we will write L square minus by BT. Okay, B into T. Okay, now what happens? B is equal to L square by T into M L raised to minus 1 T raised to minus 2 is equal to M raised to minus 1 L cube T. M raised to minus 1 L cube T. Okay. This is B. Now what happens? Now we have to find out A by B. A we are using L square. So L square by M raised to minus 1 L cube T is equal to L cube and L square will get cancelled. M L raised to minus 1 T raised to minus 1. Okay, that is the answer. Now next question is find the dimensions of A into B by C. We have to find out A and B by C. In the relation y is equal to 4 sin 80 plus 3 cos pt minus ct. So we know y is equal to distance is L. So in 4 sin 80, AT is dimensionless. So AT to be dimensionless, A shall be T raised to minus. A shall be T raised to minus. Then only it will be dimensionless. T and T raised to minus 1 get cancelled, then you will get no dimension. Similarly, BT shall also be dimensionless, therefore B should be T raised to minus 1. Okay. Again, Y shall be equal to CT. Okay, CT dimensionally. So C shall be Y by T. So Y means actually L. L by T. So it is L T raised to minus 1. So C shall be L. So A into B by C is actually T raised to minus 1 into T raised to minus 1 by C is actually L T raised to minus 1. Okay. So 1 T raised to will get cancelled. Therefore, L raised to minus 1 T raised to minus 1 is the answer. Okay. Find the dimensions of C by AB in the relation y is equal to A cos omega t plus bt minus c root t. So y is displacement, so it will be L. Dimension is L. The t is time and omega is the angular velocity. So since y is equal to a cos omega t plus bt plus ct, so y is equal to dimension of y is equal to dimension of a cos omega t is equal to dimension of bt is equal to dimension of c root t. Okay. So as cos omega t is dimensionless, y is equal to dimension of y is equal to root is equal to L. So a is equal to L. Again, L is equal to bt. Okay, which implies b is equal to L by t is equal to L t raised to minus. Okay. Again, L is equal to c t raised to half. C t raised to half. Which implies c is equal to L divided by t raised to half is equal to L t raised to minus half. So c by ab is equal to L t raised to minus half divided by a is equal to L into then b is equal to L t raised to minus 1 is equal to L and L will get cancelled here. Okay. Then L raised to minus 1, then t raised to minus half plus 1. So L raised to minus 1, t raised to half. Okay. T raised to minus 1, t raised to half. This is the dimension of C by AB. Okay. The period of revolution T of a planet around the sun depends on the radius r and radius r of the orbit, mass of the sun, okay, then gravitational constant g. Prove that t square is proportional to r cube. Okay, radius of the orbit, the cube root of the orbit, radius of the orbit. So the period of revolution. So period of revolution is actually t. Period is t. And r is the radius and m is the mass. Then g is equal to f r squared by m1 m2. So ml t raised to minus 2 into L square divided by m square is equal to m raised to minus 1 L cube t raised to minus 2. Okay. So g, dimension of g is actually m raised to minus 1 L cube t raised to minus 2. So t is proportional to L raised to a, m raised to b, then m raised to minus 1 L cube t raised to minus 2 raised to c. Okay. M raised to 0, L raised to 0, t raised to 1. Okay. Now what happens? Proportional to m raised to b minus c. M raised to b minus c, then L raised to a plus 3c. Then t raised to minus 2c. It's equal to m raised to 0, L raised to 0, t raised to 1. So we will get b minus c is equal to 0, which implies b is equal to c. Next one, a plus 3c is also 0. Again, minus 2c is equal to minus 2c is equal to 1, which implies c is equal to minus 1 by 2, When C is equal to minus 1 by 2, B is also minus 1 by 2 because B is equal to C. Okay, so B is also minus 1 by 2. Then substituting in this equation, okay, A plus 3 into minus 1 by 2 is equal to 0. So A is equal to 3 by 2. So we got A, B and C. B, C and A. Okay. So in this equation, okay, you know T is proportional to R raised to 3 by 2, M raised to minus 1 by 2, okay, then G raised to minus 1 by 2. Therefore, T square is proportional to R cube, M raised to minus 1, G raised to minus 1. Therefore, T square is proportional to R cube. That's the result. Okay, so we have to prove that T square is proportional to, we are supposed to prove T square is proportional to R cube, so we have proved it here. Okay. The frequency vibration nu of a string may depend upon length L, then tension T raised to B, then the mass per unit length. Okay. For the string, using the method of dimension, derive the formula for it. We have to find the formula for nu or the frequency. Okay. So frequency we know actually T raised to minus 1. Therefore, it is actually M raised to 0, L raised to 0, T raised to minus 1. Okay. It's proportional to L length. Length is actually L raised to A. Then tension is nothing but force. Force we know MLT raised to minus 2 or raised to B. Then mass per unit length is actually M L raised to minus 1 raised to C. So it's proportional to M raised to B plus C, then L raised to A plus B minus C, then T raised to minus 2B. Okay. Therefore, B plus C is equal to 0, which implies B is equal to minus C. Then A plus B minus C is equal to 0. Again, minus 2B is equal to minus 1. Minus G minus 2B. Okay. Minus 2B is equal to, is it minus 1 or plus 1? Okay, B minus 2B is equal to minus 1 only. That means that B is equal to half. When B is equal to half, B is equal to half, C is equal to minus B is actually equal to minus half. C is equal to minus half. Then A plus B is half. Then minus of minus is half. C, A plus B plus minus C. Okay. It's equal to 0. That means A is equal to minus 1. Okay. This means nu proportional to L raised to A is minus 1. Then T raised to B. B is half. Then M raised to C is minus half. Okay, C is minus half. Is equal to K into K by L into square root of T by M. Answer. What are the dimensions of A and B? We have to find dimensions of A and dimensions of B. In the relation F is equal to AT plus BX, where F is equal to force. Okay, force is ml t raised to minus 2. Then X is distance. Okay, Bx. X is distance. So here actually F is equal to AT is equal to Bx. Okay. So ml t raised to minus 2 is equal to AT. So A is equal to ml t raised to minus 2 by T is equal to A is ml t raised to minus 3. Okay, dimensions of A, ml t raised to minus 3. Now again, F is equal to Bx is equal to BL. Okay, so B is equal to F by L. So it will be ml t raised to minus 2 divided by L. So m t raised to minus 2. Okay, it will be m t raised to minus 2. Okay. Next one is write the equations of A by B. We have to find out A by B. Okay. In the relation P is equal to A minus T square divided by Vx, where V is pressure. Okay. X is distance. Okay. And T is time, of course. T is time. Now here we can write A is equal to T square. Okay. Again, ml, T square pressure is equal to F by A. So ml raised to minus 1, T raised to minus 2. Okay. Is equal to T square by BL. X is L. Okay. So B is equal to ml raised to minus 1, T raised to minus 2 by T square into L. So L will get cancelled. So we will get m t raised to minus 4. So we will be F is actually by Bx. Okay, B. Okay, now there was a mistake here. B is actually, okay, this not done correctly. Here there's a mistake. ml p square is equal to, see, therefore B is equal to this is wrong. It's not correct. So B is equal to, B will go up and it will be T square and L, then ml raised to minus 1, T raised to minus 2. It will come down here. Okay, so it will be L and L will get cancelled, of course. Then m raised to minus 1, then T will go up, m raised to minus 2, T raised to 4. Okay, m raised to minus 1, T raised to 4. This is the answer. Now what we wanted to find out is A by B. So A is equal to T square. So A by B is equal to T square divided by m raised to minus 1, T raised to 4 is equal to m T raised to minus 2. A by B is actually m T raised to minus 2. Okay. Find the dimensions of A, B. limits of AB in relation P is equal to A root 2 minus Bx square. Okay, where P is equal to power is equal to energy by time equal to m L square T raised to minus 2 by T is equal to m L square T raised to minus 3. Okay. And T is, as you know, it is time, and X is equal to length. Okay. So we can say, from this we can say P is equal to A root T is equal to Bx square. So P, you know, m L square T raised to minus 3 is equal to A T raised to half, which implies A is equal to m L square T raised to minus 3 divided by T raised to half is equal to m L square T raised to minus 3 minus half. Okay, is equal to m L square T raised to minus 7 by 2. Okay, this is A. Then P is equal to Bx square is equal to B T square. So m L square T raised to minus 3 is equal to B T square, which implies B is equal to m L square T raised to minus 3 by T square. Okay. So there was a mistake. That it is not X is actually L. Therefore, it is BL square. So it is actually by L square. So it is actually L square will get cancelled. M T raised to minus 3. So we have to find out A into B. A we got actually m L square T raised to minus 7 by 2 into m T raised to minus 3. Okay, therefore it is m square L square T raised to minus 7 by 2 into minus 3 is equal to m square L square T raised to 21 by 2. Okay. Sorry, it's not 21 by plus 7 by 2 minus 7 by 2 plus minus 3. So it will be yeah, it will be m square L square T raised to minus 7 by 2 minus 6 by 2. So it will be m square L square 2 T raised to minus 13 by 2. Next question. Q. Find the dimensions of AB by C. This is what we have to find out. In F is equal to A by root X plus Bx plus or minus Cx square. Okay. Now when F is false, so F is equal to ML T raised to minus 2. Okay. Is equal to A by root X is equal to Bx is equal to Cx square. So A is equal to ml T raised to minus 2 into L raised to half is equal to m L raised to 3 by 2 T raised to minus 2. Now P is equal to ml t raised to minus 2 divided by L is equal to m t raised to minus 2. Then C is equal to ml t raised to minus 2 by L square is equal to m raised to minus 1 t raised to minus 2. So A B by C, A B by C is equal to A, we have got m L raised to 3 by 2 t raised to minus 2 into B, B is m t raised to minus 2 by C is equal to m L raised to minus 1 t raised to minus 2. So t raised to minus 1 m also will get cancels. So we will get m L raised to 3 by 2 plus 1, then t raised to minus 2 is equal to m L raised to 5 by 2 t raised to minus 2. That's next one. Evaluate A, B, C in P is equal to A plus BT square plus CT cube, where P is equal to power T time. Second question is actually S is equal to AT plus half BT square plus CT, where S is displacement, T is time. Third question, F is equal to A root X plus P T plus CT square, where X is displacement. Then P is equal to B square plus AT plus CX, where P is pressure and T is time and X displacement. All this actually you can do by yourself. Okay, please try these questions. Okay, because we have done so many questions, similar questions we have done. Now you can try these questions.